Okay, so good afternoon, everyone. Welcome and thank you for attending the Heat Roadmap Europe webinar. I am Joana Neves, part of the Heat Roadmap Europe team and at Aalborg University in Denmark. As part of the project, we are hosting a series of webinars about this Heat Roadmap Europe, which is funded by the European Commission. This is the sixth in a series of 7 webinars scheduled for the spring 2018, and more will follow in the autumn. At each webinar, we dive deeper into different aspects, methodologies, and findings of this big project. And you can already find the records of our previous webinars at our website. So today I'll provide a brief overview of the Heat Roadmap Europe project. And then Dr. Tobias Fleiter, coordinator at Fraunhofer ISI, will present the data about heating and cooling demands in Europe, along with their use in the current energy systems. And this is actually a key output of the project and provides main data regarding today's energy use in Europe. At the end of the presentation, I will also welcome Daniela Torres, Officer of Built Infrastructure and Sustainable Energy from ICLEI Europe, to start the panel discussion. So I hope this will be interesting for you, and at the end we will have some time to read our comments and answer your questions. During the presentation, you can send these to the GoToWebinar sidebar on the right of your screen, or reach out on Twitter via @HeatRoadmapEU. So before we start the presentation, I would like to make a short introduction to what is the main purpose behind this project. Heating and cooling in houses, services, and industry represents half of the entire energy demand in Europe. This makes it a major part of any effort to decarbonize the energy sector and try to reach both of the targets set out in the Paris Agreement. However, until very few years ago, it was largely neglected in the political discourse and also in scientific analysis of 100% renewable energy systems. And is that in that sense that Heat Roadmap Europe aims to address this gap and to provide the strategies that can contribute to the decarbonization of the European energy systems. In Heat Roadmap Europe, we are building on research that started in Denmark and Sweden more than 5 years ago. At this time, the project has grown both in terms of scope and in terms of partners and expertise. The first Heat Roadmap Europe study, we look to see if district heating was exclusively Northern and Eastern European technologies. On the second Heat Roadmap Europe study, specifically, we addressed the synergies between energy savings and sustainable energy supplies through heat pumps, biomass, and district energy. Then in the third Heat Roadmap Europe, which was part of the Strategico project, we focused on developing holistic country-specific roadmaps for heating and cooling, including both rural and urban energy systems. Finally, in Heat Roadmap Europe 4, we are now building on this knowledge and developing integrated and comprehensive roadmaps to decarbonize the heating and cooling sector in the 14 EU countries with the largest heat demands. So in order to do this, we are a consortium of 14 research partners and 10 advisory members. These include specialists in many different areas, such as energy mapping, energy modeling and transitions, industrial energy cooling, energy systems optimization, and also local governments. And together we started this project in 2016. And it will continue until next March to develop comprehensive strategies to decarbonize the heating and cooling sector. So our purpose is to create scientific evidence to support long-term energy strategies at local, national, and EU level, and to empower the transition to a low-carbon energy system. And we do this by quantifying the impact of various alternatives for addressing the heating and cooling sectors. So to make a transition, we need to address the problem from both the bottom and from a wider point of view. For instance, it is important to first consider the geographic location of the demands for heating and cooling and the resources that are available for renewable and sustainable heat and cold sources. Secondly, a detailed profile of the wider energy system has to be made, including what kinds of energy are being demanded in different building types and industrial process, and what are their potentials for savings. At the same time, the decarbonization needs to allow for more renewables in the power and transport sector as well. And for these, tools and methodologies for energy system modeling and analysis are necessary too. In order to facilitate the energy system transitions, we need the roadmaps we develop also to be technically and socially, socio-economically feasible. So how do we do all of this? By using the data on the demands in the built environment and industry, we develop an understanding to what extent and at what cost it is possible to reduce heat and cold demands in the future. For this, we mainly use the outputs developed in the forecast model. Using the geographical mapping of the demands and the resources available to us with the PETA tool, we can investigate the potentials of heating and cooling infrastructures, in particular district heating. These are then incorporated in an overall perspective of what could be the potentials of the energy system by using times and the energy plan models. So by combining all these, we can make scenarios of what is the best mix between energy savings and sustainable supply of energy, and between district heating and individual supply technologies, like heat pumps and biomass boilers. And the combination of all these elements will then create the integrated strategies that are necessary to actually empower the transition to decarbonized heating and cooling systems, and in extension, low carbon and renewable energy systems in Europe in the future. So far, we have reached some recommendations. For instance, we conclude that there is a potential for reducing the heat and cooling demand up to 50% if energy savings are applied everywhere. In urban areas, the heat supply could be reduced in 50% if district heating is expanded, especially to all high heat density areas. And finally, if electric heating with heat pumps is implemented in rural areas, together with the integration of renewables, this could also lead to a reduction of 50% of the heat demands. Overall, we believe that through integrated heating and cooling planning, as we do in the roadmaps, it is possible to simultaneously reduce energy consumption, reduce fossil fuels or carbon dioxide emissions, reduce energy costs, and all this while increasing renewable energy consumption and increasing the number. So now, after this short introduction, I welcome Tobias Fleiter, who will give a deep dive into what has been happening in the energy profiling in Europe. And following his presentation, we will have Daniela Torres to start the panel discussion. If you have any questions about this or during the presentation, please remember to write them in the comments bar or tweet us. So with this, I welcome Tobias to start his presentation. Thank you.
Thank you, Joanna, for the introduction. Yes, my name is Tobias Fleiter. I'm working for the Fraunhofer Institute for Systems and Innovation Research in Karlsruhe. We have coordinated the work on the 2015 heating and cooling profiles in Heat Roadmap Europe, and I'm now happy to guide you through some interesting results and our methodology that we have used in the coming 30 minutes. So, starting of course, yeah, I'm going to start with the goal and motivation method and then focus on the results and have some conclusions in the end. Most important to mention, all this has been teamwork. So we worked together with the University of Utrecht, with TAP Energy from Switzerland, and with Amin Paris, mostly for the cooling part. So each partner focused on a certain sector and on their main field of competence. And yes, the main goal of all this has been to disaggregate heating and cooling demand by including end users and technologies for the year 2015. This means we extend the Eurostat energy balances, which only show sectors and energy carriers, by also including end users like space heating, process heating, and technologies. And then show a much more detailed picture of the heating and cooling sector in Europe. So, why is this needed? There are three main reasons. The first is more Heat Roadmap Europe methodology reason. We simply need these profiles as input for the Pan-European Thermal Atlas, which takes this national heating and cooling demand and distributes it to the local level, to the regional level. And second, we also in the project need the 2015 profiles as a foundation to then develop scenarios towards 2050 and the future evolution of the different demand areas. And third, this is maybe the most interesting part, it also has a purpose for itself. We actually fill important gaps in national and EU energy balances, which I will illustrate on the next slide. So what you see here is the Eurostat energy balance as a Sankey diagram. This is just downloaded from the Eurostat website. You can start on the left side with the upstream generation, transformation, imports, exports, and then at some point we come to the final energy demand, which is broken down to different sectors: industry, transport, others, and then further to subsectors like different industrial sectors and the services and residential sectors. So what you see here is energy demand, final energy demand by sector, subsector, and energy carrier. What you do not see is how much of this is used for heating and cooling, what is the need for space heating, what is the need for cooling, and which technologies are used. And that's exactly what we are going to add to this Eurostat energy balance, or what we actually did in the project. You might wonder if maybe Eurostat does not provide this data, maybe the national energy balances are more advanced. And this data could also be gathered by simply combining national energy balances. So in an earlier project, we had a look at that, and we assessed in how far actually the different European countries provide end-use energy balances. So energy balances that not only show sectors and energy carriers, but also, for example, the share of space heating, process heating, etc. And we found that some countries do provide this. Often they do it only for the household sector, for the residential sector, and so there are some gaps. And even all the countries that provide this, they use different methods. So some use models, others do empirics, others combine it. For some countries, it's unclear what's the method used. So that in the end, we came to the conclusion that it will not be possible to collect from the country energy balances a consistent European end-use balance because the system boundaries are different, the definitions are different, the methodology is different, etc. This would not lead to a consistent data set. So we have followed a different approach. Before I explain it, I briefly show you what we actually looked at, or what is it we wanted to calculate. So what you see here is in the left two columns what Eurostat provides, different energy carriers, final energy demand, and the different sectors, but there's no information on the end users. So what is this energy used for? And also no information on or nearly no information on the technologies. You cannot draw conclusions on the heating and cooling sector because it's a cross-cutting sector that is part of all these residential, tertiary, and industry sectors. So what we did is we extended this by first including subsectors to different sectors, for example, the industrial subsector, tertiary subsectors, and split residential and single-family and multifamily houses. And then we added end users like space heating, water heating, space cooling, process heating for different temperature levels, and also process cooling for different temperature levels. And we also at some parts included technologies like heat pumps. Because not only interesting to know how much is used for, how much electricity is used for space heating, for example, it's very interesting to see how much of this is used for heat pumps and how much for electrical resistance heating. So how did we, or what type of energy did we include? We start here with final energy. Final energy is definitely the, also here the most interesting energy form we looked at, and all the further slides that I show you actually show final energy. However, there's also delivered energy available, which is based on final energy, but including the transformation step in the heating system and also losses in the heat storage. What we do not include in the Heat Roadmap Europe project is useful energy, which would in this case also include losses in the distribution, for example, in the pipe system in the buildings or in the industrial steam pipe system. So this is not included. But in the coming slides, I focus fully on final energy. So now let's briefly have a look at how did we do that. We used an approach that is actually based on a bottom-up model, the forecast model, combined with collection and primary data input. So this model is, we are developing this model since nearly 10 years. I have used it in many projects, and it's a very detailed bottom-up model for the industry, residential, and tertiary sector. It develops scenarios for energy demand based on changes in the technology structure, in the activity structure, economic growth, etc. So it's a more techno-economic bottom-up model, and yes, this we used for to prepare to develop the end-use energy balances, or the heating and cooling profiles, as you can also call them. The main advantage of using this model is that the methodology, the system boundaries, the approach definition in the different countries is fully comparable. So the data set is completely consistent. Differences might only occur due to difference in the input data, but also here we mainly used European sources that include all the countries. So here we also have a very high consistency. Only briefly to mention, in 2012, we have published a first version of this data set in a tender study for the European Commission. This data set, however, did not yet include technologies, was not yet so detailed on cooling, and had less indicators, and is for earlier year now. So we have much more comprehensive data set now. This slide is an example for the methodology for the industry sector. I will not go into details here. If you're very interested in the methodology, I invite you to have a look at the publication that that you see here at the bottom of the page. The basic idea is that we calculate energy balances based on bottom-up data. For example, here we distinguish about 60 industrial energy intensive processes, for example, paper production, and the input is then the paper production in terms of tons of paper produced by country, and the specific energy consumption for this, which allows us to calculate the amount of energy used for paper production, which is compared to the overall pulp and paper industry, a very specific process. And then it's easier to add shares of or distribution across temperature ranges and end users. So we have much more accuracy here. But of course, we in the end calibrate and compare the this bottom-up energy balance to the Eurostat final energy balances in order to have a data set that is consistent with the Eurostat energy balances. So as I said, if you're really interested in the methodology for the industry sector, I invite you to have a look at this publication. So in terms of data sources, we used a lot of data as input to the model. On the one side, this is technology data. On the other side, this is activity data like industrial production of different products, steel production, flat glass, container glass, paper, chemical pulp, mechanical pulp, a lot of about 60 different products for the residential sector. Also, of course, data on the dwelling stock, on the buildings, and on technology shares, etc. So let's have a look at the results. What did we find out? To start with an overview, so the most often shown figure in Heat Roadmap Europe is probably the importance of heating and cooling. This is a result of our profiling work. About 50% of the total EU28 final energy demand is used for heating and cooling. So heating and cooling has a very high relevance and needs to be considered in every decarbonization transition strategy. Within heating and cooling, space heating and process heating have the higher shares. Cooling actually has a very low share on the EU28 average, space cooling about 1%, process cooling about 1%. In the southern Mediterranean countries, this is a little bit higher, as we see here. So we have the same end users here shown by country, and you see in light blue, space cooling is important in southern countries, Cyprus, Malta, but also this is Italy, Greece, Portugal, Spain, but still also in these southern countries, space heating is much more important than space cooling. Exception is Malta and Cyprus, and actually we see that in all countries space heating is dominating. But also most countries have quite a substantial share of process heating. So let's look at energy carriers. This is the total heating and cooling demand in the EU28 and the share of the different energy carriers used for heating and cooling. And what we see instantly is the high importance of natural gas with more than 40%. In total, fossil fuels account for about 66%. And if we would look at primary energy, so also taking into account the fossil fuels used in electricity and district heating generation, this share would be a lot higher, probably above 80%. In terms of renewables, we have in total a share of 13%. However, this is mostly biomass with 12%. And then we have electricity with a high importance, and also district heating here with 9%, and coal with 8%. So let's look at how is this distributed among the different countries. We see much more diversity here. So also here, natural gas is important in many countries, but there are also quite some countries where natural gas is not so important. For example, in the Nordic countries, Sweden, Finland, we have a very low share of natural gas. Instead, we have high shares of district heating and also biomass. And other countries have lower shares of natural gas. Instead, there is more oil used, and particularly coal. For example, in Poland, here we have a lot of coal use. But in total, a very diverse picture in terms of energy carriers that mainly comes from different resource availabilities, different developing pathways, and also different structure of demand and industrial structure. Solar and heat pumps are marginal in all countries. They are growing, however, yet they still have very low shares in most countries. So if we look at the regional distribution across Europe, for example, for district heating, we can see very interesting patterns. We can see that district heating, this is only for the tertiary sector, so the share of district heating in the tertiary sector, we see that it's very important in Nordic countries. There is also very high importance in the Eastern, Central European countries. But there's a very low share of district heating in very large Southern and Western European countries, UK, Spain, Portugal, Italy, Greece have very low shares of district heating. Although we've seen that they have quite substantial space heat demand and also process heat demand. So let's look more at the different sectors. We distinguish the industry, residential and tertiary sectors. And we first can see that the residential sector is the highest heating and cooling consumer in the EU 28. It, of course, mainly uses heating and cooling, has space heating demand, but also some hot water and some other heating, which is cooking actually. And the industry, of course, mainly uses process heating, but has also quite some space heating demand. And the tertiary sector is the most diverse, but also the smallest consumer. If we stick to the sectors, but now do not look at the end users, instead we look at the energy carriers as share of the total final energy demand for heating and cooling in the sectors. We see that in all sectors, gas is very important, or is the most important energy carrier. We can see that for industry, there's also quite a substantial share of coal. In the residential sector, we have a bit more biomass, and in the tertiary sector, there's the highest share of electricity, which also I think mainly reflects the relatively high cooling demand compared to the other sectors. So let's now explore the industry sector. The picture looks very different here than in the average. So here we have a very high share of process heating. I mentioned that already. We actually have about 50% of process heating demand above 200 degrees Celsius. So the red part, which is heating in industrial furnaces mainly, or actually the part above 500 degrees, which is 40%. It's industrial furnaces in the basic materials industry, steel, cement, etc. We also have a substantial share of steam demand. This is 100 degrees Celsius to 500 degrees Celsius, 30%. This is a lot in the paper industry, but also chemicals and food. And then there's a certain demand for low temperature heat in gray below 100 degrees Celsius, and also also space heating is quite relevant in industry. Yes. Looking at the allocation of the end users by subsectors, so we go even a level deeper now. We can see that, as I mentioned already in red, dark red, the process heat demand above 500 degrees Celsius is a lot in the chemical industry, in the steel industry, which is the highest, the biggest heating and cooling energy consumer in the EU, and also in the non-metallic minerals industry. And this is mainly cement production, but also some glass production, lime production, ceramics, etc. Interesting to know is that this part is very difficult to decarbonize. So the potential for renewables is not very high. There's actually only some co-firing of biomass today. Yes, there's also other temperature levels, as I mentioned, the 100 degree in yellow, the 100 degree to 200 degrees Celsius, which is steam mainly. You see the pulp and paper industry here, but also the other industries and the food industry, the chemical industry that have some steam demand. This has a high potential for combined heat and power, and yes, also for biomass and steam boilers. And then we have process cooling. Process cooling is only to some extent observed in the food industry and also the chemical industry, and the others have very low shares. But even in the food industry, it's not the biggest part. So in total, a very diverse picture across the different subsectors, and the importance of different subsectors also varies by country. Now we still stick to the industry, we combine the energy carriers and the end users. And what we can see here is what everybody was guessing probably already, that coal is used for process heating above 500 degrees mainly. So there's a lot of coal here, but also a lot of gas and other fossil fuels. Biomass is used a lot for steam generation and combined heat and power, but also boilers. This is yes, mainly because the pulp and paper industry has biomass residues from the paper production that can use for heat generation. So we can also compare individual countries with the data set. For example, here Italy and Sweden. Sweden with a very large pulp and paper industry. We can see that in the pattern here in the final energy demand by end use, that there is a very high demand for steam, and this is mainly supplied by biomass. So that's dominated, or there are two reasons. One is the high importance of the pulp and paper industry, and the second is also the availability of wood resources in Sweden. Italy has a broad mix of industries, and there is, so the pattern here follows more the EU 28 average. Gas is very important in all these sectors, in all the different end users. So biomass is also very interesting to look at on a regional EU 28 level. So here we can also see what was already mentioned, that biomass in industry is used a lot in the Nordic countries due to resource availability and also importance of the pulp and paper industry. But also Austria and Portugal use some biomass. Other countries have a lot lower shares. So let's move to the residential sector. We see a totally different picture here. The residential sector is completely dominated by space heating, with some hot water, some other heating, and a little space cooling. And this is also the same picture across all the countries, and even the Southern European countries have a high share of space heating. That's, I thought, interesting to see, although it is a bit lower than the EU average. And also space cooling can be observed in the Southern European countries here, but even there, it's not the major part. Cyprus and Malta are a bit an exception. So, as in the industry sector, also in the residential sector, natural gas is the most important energy carrier, for more than 40%, followed by biomass, oil, electricity, district heating, and coal. And even here, heat pumps and solar thermal have low shares of about 1%. Yes. What is interesting in the residential sector, we can even split the residential sector more into detail, and we can distinguish between the single-family buildings and the multi-family buildings or households. And interesting to see that actually here's the space heating for single-family households in the EU 28, and it's twice as much as the space heating final energy demand for multi-family houses. So we also see that the pattern is different in terms of energy carriers. Multi-family houses use more district heating. Single-family houses use more biomass, less district heating, more electricity. And this is also very relevant in terms for policy making and for developing renewables and decarbonization strategies. Very interesting is that this is also different in the individual countries. So here we see the share of single-family houses and total space heating final energy demand by country, And we observe some countries like, for example, here Ireland and UK, with very high shares of space heating, and other countries like the Mediterranean countries with relatively low shares of single-family houses. So it might be that the that policies need to focus. Definitely, policies need to focus on different building types than in these different countries. And already shows how difficult it is to define one policy set on the EU level that fits to all the countries. Let's have a quick look at cooling. I mentioned already cooling in total today in the EU 28 is still marginal. It has some importance in the Mediterranean countries, but also there it's not yet as important in terms of energy demand as space heating is. But if we look at the share of the floor area cooled by country, we can learn quite some interesting conclusions about space cooling in Europe. So what we see is in orange is the share of the floor area that uses space cooling in the tertiary sector, and in blue we see the residential sector space cooling share. So Italy and Spain, the tertiary sector is nearly completely using space cooling, while in other countries it's below 30 or 20% of the floor area and goes down to below 10%. In the residential sector in total, we are a lot lower. Even in Italy and Spain, it's between 20 and 10%, and then it goes down to below 10%. So this is actually an indication of the future growth potential. Space cooling energy demand shows a growing tendency. Sales of cooling devices are increasing. And as we can see here, the potential is still huge. If we assume that other countries would have a share for would have a cooled floor area share as high as Italy and Spain, the growth would be tremendous. Or if the residential sector would come closer to the tertiary sector. So there's a huge potential for growth in the coming decades. So this was a quick tour through our data set. I invite you all to explore this data yourself. We have made all this data available on the Heat Roadmap Europe website. You see the link to the website on the top of the page, and you can explore the Excel spreadsheets there. They also include already predefined figures and tables. You can dive into the individual countries and sectors on the website. So to summarize some main conclusions, this data set is the, I would say, most detailed, complete breakdown of heating, cooling, energy demand for the EU 28 countries, down to end users and technologies. It has a very consistent methodology and approach. And yes, it extends the Eurostat energy balance. It can be used as the basis for developing transformation strategies towards low carbon heating and cooling sector. For example, it was already used as input to the heating and cooling strategy proposal from the European Commission. But of course, there are still uncertainties and there's room for improvement. Much of this is related to the input data. Better empirical data, for example, for the use of renewables in industry, services, but also the residential sector on space cooling, etc., could substantially improve this data set. And now some conclusions on the content. We've learned already the most important figure. Heating and cooling is extremely important, with about 50% of final energy demand in the EU 28. However, the composition of energy carriers is very diverse across the countries. Still, we've seen that for EU 28, yet it's mainly based on fossil fuels with more than 65%. If converted to primary energy, we would be above 80% fossil fuels in heating and cooling. Gas is the most dominant fuel in the EU 28, but also in most individual countries and in most sectors as well. Renewables, in terms of renewables, mainly biomass has high shares in many countries and sectors. Solar thermal, geothermal, heat pumps are still marginal in almost all countries, although they of course have a growing tendency. District heating is very strong in Nordic countries, Central and Eastern countries, and is marginal in other countries, mainly the Mediterranean countries and also UK island. So, more conclusions on the end users. Space heating and process heating are the most relevant end users. Space heating for single-family houses is twice as important as multi-family houses on the EU average. There are many differences on the national level. For process heating, we've seen that the temperature range above 200 degrees Celsius is about 50% of heating cooling demand in industry, and it is very challenging to decarbonize, and there are many limits in switching to renewable energy sources. Cooling today accounts for only 2% of final energy demand in heating and cooling. However, we've seen that the saturation is still very low and there's a huge potential for growth in the future. Yes, and of course, the local situation is always different than the country averages that I have shown here. So I thank you for your attention, and I invite you to explore the data set yourself. On the website, we also have available a brochure, country fact sheets for the 14 largest heating and cooling consumers in the EU. There are also guidelines and, of course, technical background reports available. And with this, I hand over again to to Daniela, right, for reflection.
Thank you, Tobias. Thank you so much for your comprehensive presentation. It was very interesting to understand how the heating and cooling demand is being used in Europe. So now I would like to welcome Daniela Torres to open the panel discussion. Please, Daniela, what are your reflections on this?
Hello, Joana. Thank you, Tobias, for your right presentation. It was very clear for us. Just a short introduction on myself. Well, I have recently joined ICLEI, working specifically in sustainable energy and build infrastructure projects here in the climate and energy team. And I am particularly working on the Thermos project, that is a twin, or I don't know, very sister project of the Heat Roadmap project. And after evaluating the information of the project of Heat Roadmap Europe and the results of this energy profiling, certainly I am very impressed of the results you have achieved. From an ICLEI perspective, we totally welcome all these results, because on a general terms, there is a lack of information on final energy consumptions everywhere. Most of local and national energy planning is done based on sectoral energy final consumption. So having data specifically on heating and cooling on an industrial level and space level on a household level is very impressive, and although there's no information on regional and local level, it gives a very good input for future energy planning also on a local level. Taking this as a reflection, this valuable information that we are now seeing in this energy profiling, it's very important to know that that on a local level, most energy planning has been done based on energy consumption of the different sectors. Okay, but there's very non data of of this detail of industrial processes, how much energy or how many heat is consumed in different industry processes, that is of great value. So we think that with this information, also local governments, regional governments will be able to prioritize their actions on energy efficiency on an industry level or building level, especially because there's a good moment now because of two things. First, because now cities and local governments are now starting to develop their sustainable energy and climate action plans, which of course in European level, heating and cooling are key issues on their mitigation goals. So I think that having some information on final energy consumption with detail is very important to understand where to put the resources to develop more energy efficiency practices. And on the second hand, is that cities also, and one of the projects that we are leading here in ICLEI with the Thermos project, is that cities are starting to do specifically energy planning for district heating and cooling. And our Thermos project aims to do that. It's a software that helps cities to better plan their district heating networks and services. So it's a very good moment to have this information. I think for cities, this would be very useful. Cities can establish priorities of action, can accelerate also the identification of industries or sectors to implement measures. So I think it's a very interesting and very well comprehensive information. This is as a general conclusion on my side.
Yes, thank you, Daniela. We have some questions from the audience. Kapil Narola is asking. He is asking if we can give some input on the share of technologies such as heat pumps and boilers used for heating demand. Tobias, would you be able to answer this question?
Yes, I mentioned technologies in the beginning, and then I did not show them so much in the presentation. There is actually on the data set available the share of heat pumps in different sectors, countries, and end users. And for industry, we have also included the shares of different steam generation technologies, so different combined heat and power technologies, and different individual boiler types. Yes.
Yeah, thank you, Tobias. We have another question from the audience, from Carolina Carmo. She says, would it be possible to know what is the main energy carrier of district heating plants?
Yes, that is also a good question. As we've looked at final energy, we have only shown district heating as an aggregate. So we did not break down the generation in district heating. This is not included in our data set actually, because it would be on the level of primary energy. This, however, is available at also at Eurostat and even in older heating and cooling energy balance that we have calculated in 2012. So if you are really interested in that, I invite you to send me an email, and I can forward you some more information on the primary energy side of the heating and cooling sector, and especially the shares in district heating supply.
Okay, thank you very much. Daniela, would you like to ask some question to Tobias?
Yes. Thank you, Joana. Yes, Tobias, I have one question that also because I am from Spain that worries me a little. But during the results of the energy profiling, you are showing that present cooling demands in Europe are not as relevant as heating demand. Of course, with the exception in southern countries like mine in Spain. But recently, a study from the International Energy Agency mentions that due to the effects of climate climate change, future demand of cooling capacity will be demanded along the world and also in Europe. So I don't know if during your analysis and your scenario development, you consider this issue.
Yes, I indicated already that there is a large growth potential for space cooling demand. And what I did not mention yet is that we have another work package in the Heat Roadmap Europe project where we develop scenarios until 2050 of exactly these profiles. So we have calculated the same profiles also for 2030 and for 2050, including space cooling share. For space cooling, there's a separate report available on the website. Amin Paris has worked on that. They have developed a very detailed bottom-up model with the different cooling technologies, devices, stock data, sales data on cooling devices in the European countries, and have done a projection of the cooling demand. It was interesting to see that actually in the cooling demand is increasing, but at the same time, in the coming decade, also the efficiency of the devices is increasing. So with the same electricity input, we can the units produce more cooling energy, and this, at least in our scenario, compensates the increasing or the growing demand in the next, let's say, 10 years. This is very much dominated by the minimum standards from the EU Ecodesign Directive. But after 2030, we see a more steeper increase than also in the not only in the cooling demand but also in the electricity used for the cooling when efficiency improvements are saturating, etc. I don't have the exact figure in there for the electricity demand for space cooling in 2050, but I think it doubles or triples until 2050, and that is not a very optimistic scenario. I think it can be even more. At the same time, space heating demand, due to building regulation and a more saturated sector, space heating demand will probably decrease even with today's policies. And so the relative share of space cooling will increase a lot in the future. And yes, this is important to anticipate also.
Okay,
I hope that answered your question somehow.
Yeah.
So there's a report on everything on that on that website.
Great, thank you. Daniela, do you have any more questions?
Yes, I have only one more, because as you know, also cities are in the process of starting to get information on final energy consumption through their energy and climate action plans. I was wondering, Tobias, that from the sectors you analyzed, which one presented more difficulty to gather information, as a primary data collection? Because we know that data is always a problem, but in your experience, where were the most difficult data to be obtained when you were doing the analysis?
Yeah, I think difficulty in terms of data availability, there is definitely the tertiary sector that is very difficult because there's a high diversity of different uses, etc., and there's not much data available. So this was certainly a challenge, and we also had to fill data gaps doing analogies between countries, between similar countries, etc., for some input data. And also the industry sector is also very diverse. So actually, you can hardly analyze the industry sector as a whole. You always need to go down to at least to the subsector level, and then you don't have one sector, but you have 7, 8, or 9 sectors, and like the workload and also the time you need to develop that is exploding. So these were definitely most challenging. What for local analysis, of course, as I mentioned already, the local level is also very different. If there's one steel plant in a region, the whole energy balance is dominated by that steel plant. If it's a paper plant, it looks totally different. So I would be very careful in using these balances on the local level on an aggregated scale. However, if, for example, on the local level, it's known that there's a very high share of the paper industry, I think only the results on the paper industry can be very illustrating also for the local level, because then it's already corrected for the different structure of the industry. But the main target group of this data set is clearly the national and EU level policymakers, and then of course we have the PETA for the Pan-European Thermal Atlas, where we break all this down to the regional level and where a lot more local details can be extracted.
Okay, thank you very much for answering, Tobias. Daniela, actually I have some questions for you. I don't know if we have time for many, but for example, HRE Europe energy profiling provides insights on the relevance of heating demand on industry and building levels. So which kind of policies can be implemented on a local level to enhance local heating energy efficiency?
Thank you for the question, Joanna. Well, I think that it would depend on the city. Again, we cannot generalize the policies that could be implemented on a city level. But I think that specifically for heating and cooling, we have to understand the moment on time that the networks of heating and cooling in the cities are having. For example, cities that are in the process of expanding their networks, they should develop investment policies or policy or incentives for new investment in infrastructure. But on the other hand, if you have cities that have, for example, industrial parks, and they want to promote energy efficiency in the industry and through new district heating networks, like for example in granularies in the Thermos project, we could think of other type of energy efficiency policies. So, but I think that in general, incentives to investment, promoting new technologies for energy efficiency also on an industry and household level is also necessary. But to summarize, well, each city is able to with good information to establish the correct policies to drive district heating and cooling infrastructure in their territories. Knowing their energy sources is also very important for a better planning process.
Thank you very much. And maybe one final question before we finish. Again, Daniela, how do you think energy profiling on the local level can be developed in the future within a smart energy and a smart city context?
Well, I think that that most of the cities that are now working on smart energy, on smart city projects, I think that with all of the network of sensors that we will have on energy management processes or smart grids, smart energy grids on a local level, this will contribute to improve the energy profiling on a local level. No, cities are going to start understanding final energy consumption probably in real time. So of course, energy profiling on a city level will be better. Of course, this local profiling cannot be complete if there's no multi-level analysis within national energy policies or regional energy policies on smart grids or smart energy. So I think that energy profiling in a future smart context will be clearer, and there will be lots of information for better decision making. No?
Thank you, Daniela. Tobias, do you have some comment on this or some questions to Daniela?
I've already reflected a bit on the local level. I think Daniela has much more knowledge on how this can be relevant on the local level. So I'm happy about her insights there, and I think I don't have much to add actually. If there are no other questions.
Okay, so thank you very much. It seems that we are almost at the end. I hope this has been helpful for you, and thank you again, Tobias, for your presentation. Thank you, Daniela, for joining our panel discussion, and thank you for everyone for attending. If you have any further questions, please do not hesitate to get in contact with us. The recording of this webinar will be soon available on our website and YouTube channel, together with the previous ones. And our next webinar and last one before summer will be on Wednesday, the 30th of May at 2 p.m. And it will be an immersion into the energy savings potential in buildings and the importance of low temperature heat demands. Ulrich Fleiter from TAP Energy will present the methodology about calculating the costs of reducing heating and cooling demand in buildings, while Martin de Groot, head of research at the Buildings Performance Institute Europe, will provide his reflections. So if you are interested in this, please register on our website. And thank you again, and have a nice afternoon.